have logical operators in programming, and for this case in Python. In Python, we have three logical operators, AND, OR, and NOT. They are used to model complex conditions. We'll use a real-world example of using a logical operator in Python. We'll assume that we want to assess the loan creditworthiness for someone who wants to borrow a loan. Let us use the following variables: high income equals to true, and good credit equals to true. We'll set the condition that for the loan applicant to qualify for the loan, they have to have a high income and good credit score. So that means we'll have it as high income. So if high income and good credit, then print eligible. Let's try that. Now, so these are our two variables. So let's say that we have this: if high income and good credit, full column, look at the indentation, then print eligible. Eligible like that. Then we save, then we run this. You'll see that it will print eligible. So that is when we run this program, we'll get the output eligible. So note above that we have not given the value of the variables, i.e. high income equals to true. This is a common error for many beginner programmers. We do not need to indicate this because high income is a Boolean expression and will evaluate to either true or false. We do not have to convert true to true. This means that if the first condition is true and the second condition is also true, then we will print eligible on the terminal. Run the program and you'll see eligible. However, if one of the conditions is false, then eligible will not print on the terminal. So let us add an else statement to take care of that. So let's add another statement. Now, so we have high income equals to true, good credit equals to true. Now we have the if high income and good credit, we print eligible, else you print not eligible. So let's see. What about if we change this to false? Let's change all of them to false, then you save, and then you run. You'll see that it will print not eligible. Let me clear this, then print that. You'll see that it will print not eligible. So when we run the program, it will evaluate to not eligible. This is how the AND operator works. With the AND operator, if both conditions are true, it will result to true. With the OR operator, so long as one condition is true, it will evaluate to true. That means if we replace AND with OR in the program, it will evaluate differently. That means if we let us change and see the output. So I want us to change this to OR, then we evaluate. Initially, it was not eligible. Let's see. Right now, what will we get? It is now eligible. It will print eligible because we've changed this, because either one of the conditions, although not both of them are false. As long as we have one condition being true, it will print to true. That's why we have eligible here. Now, it will evaluate true. Let us look at the last logical operator. Let me define a new variable, student. So student equals to true. So if not student, print eligible, else print not eligible. The not operator inverses the value of the Boolean. In the case above, student is true, and so when you apply not operator, it becomes false. That's why the print eligible statement will not be executed. So let's try this. Now, we have this, commented out this other one so that we don't get printed that. So that we have another variable student, which is true. If not student, you print eligible. Else, you print not eligible. And when you run this, you'll see that we have this. not eligible, because we've introduced this. So if student was false, and then we apply the not operator, our condition will be evaluated true, and therefore the print eligible condition will execute. You can try that. You can try that. So these operators, we can model even more complex operators. And I want us to look at an example. Maybe we have the condition that the loan applicant should have a high income, good credit, and not a student. That means if high score or good credit and not student, print eligible, else print not eligible. Here we have separated student from high score and good credit because we want at least one from these two to be true. The result of this should be true, which means at least one of these conditions should be true. So we are able to model all kinds of real world scenarios. So I want us to try this. So this is the program. We have student equals to true. Student equals, so this is the program. We now have student equals to true, high income equals to false, good credit equals to true. So one of these has to be true in order for this to be true. So if high income or good credit, and you can see at least one of them is true, and not student. So that means this should also be false. So not student, here it will be false because the student is true. So we'll get false. So false and true is false. Else print eligible. That's why when you run this, you get not eligible.